So we have the ideal Rankine cycle. Okay, so first, do you have your state table with you? Raise your hands if you do. Okay. And so we proceed. So a steam power plant operates on the ideal Rankine cycle. So the steam enters the turbine at 7 megapascal and 550 degrees Celsius. It discharges and to the condenser at 20 kilopascal. So we need to determine the cycle efficiency. Okay. Anong una yung gagawin, class? Solution. You draw the schematic diagram of the simple or the ideal Rankine cycle. Dapat alam niyo na to. Here the boiler, the turbine, so close the condenser, after that the pump. From point 1, 2, 3, 4. Sa turbina, we have to work this generate electricity. We have also the condenser at point 2 to point 3. So, meron tayo dito, heat is rejected. Ay, mali yung arrow. Ito na. So, heat is rejected. While here, we have the work of the pump and heat added at the boiler. So this is the first. This is the schematic. Also, if we have the schematic, you will draw the TS diagram. Masyado ba mabilis si ma'am? Kasi 9:30 lang. Hanggang 9:30 lang. So, we have TS. Ano yung given sa ating class? We have the pressure at point 1. This is the pressure line. This is also the pressure at point 2. Ayan. Since given sa problem, this is your TS. That is a, ano yung given sa atin? 550. Okay, so pantayan class yung 550 nyo. We have, but before that, drawing the TS diagram, we need to consider what is the given in the problem. That is 7 MPa and 550 degrees Celsius. Ang given sa atin, mamaya i-continue natin. Temperature at 1 is 550. Okay, what is the T saturated of 7 MPa? No page yan. Page 12. T sat is 285.88. Therefore, yung temperature 1 natin is greater than the C at saturated. Therefore, upol siya sa superheated vapor. Okay. So, saan ka pupunta? Punta ka sa table 3. Anong page? You have your 7 MPa. Yan na. Okay. So, this is page 69. Okay. So, page 69. Page 69. So, ano yung kukunin natin? Importanteng property. Okay, so finding all the cycle enthalpy and the other important properties values when it comes to thermal efficiency. Okay. Page 69. Ano yung property na kukunin natin na importante? What do you think? So, H1, what is H1? Point 9. Ano pa? From process 1 to 2 in a Rankine cycle, no class? 550, we have 350.9, and we have also the enthalpy at point 1, 6.9486 per kilogram Kelvin. So, bakit yan lang yung kinuha? Kasi mahaba-haba to class. Since superheated na si point 1 natin, yan, pakita ko na. Most likely, ganito yung lalabas natin na okay. Pangit ng drawing ko. Yan. So, 550. So, this is now your point 1. But we all know that in point 1 to point 2, that is isentropic expansion. So, Pababa yan, class. Okay. Check natin kung mag-follow sa wattage. Okay. So, from process, red pala. Masulat ko. It falls under isentropic expansion. Ano class yung given temperature natin? Pressure 1 and the steam turbine enters at 7 megapascal and it is to condenser at 20 kilopascal. So we have the pressure 2 at 20 kilopascal. Sa steam table nyo, makikita nyo is MPa. Convert it into MPa. What is now your pressure? Pressure at 0.2. Sige nga, walang nag-chat. What is the pressure at 0.2? If we have 20 kilopascal. What is the pressure? Anyone? Okay, so we have now 0.02 MPa. So this is now your properties. Pressure 1 and pressure 2. Yes, class, because pressure 1 is just equal to pressure at 0.4 and pressure 2 is equal to pressure at 0.3. So this is the constant pressure. Yan. Constant yung pressure. So we have now 0.02 MPa. Anong table? Punta ka ulit sa table. Table what? Table 2. Okay. Table 2, 0.0202. Page 8. Tama ba? Page 8. Ayan. Tama, class. Page 8. So, we proceed. We have now the pressure at 0.2. Ano yung gagawin natin? We all know isentropic expansion using this value. So, find now the take note yung SG natin dito is ilan? Entropy at saturated vapor 7.985. Okay, so mas mataas si SG natin kaysa sa S2. And considering na yung SF natin, saturated entropy at saturated liquid is 0.832. So, mas malaki naman yung S2 natin sa SF. So, automatically, wet region. Okay? So, therefore, hahanapin natin yung quality at 0.2 using this formula. Kasi alam na natin yung specific entropy at given 0.2. SFG2. So finding the quality at 0.2, we have the S2 minus SF2 over the SFG2. Finding for the quality using the property of 0.02 MPa at table 2, your S2 now, your quality is what? 86 kilojoule per kilogram Kelvin. SF is 0.8320. All over yung SFG mo, ilan? 7.0 66 kilojoule per kilogram Kelvin. So we have now the quality at point 2. Okay. What is now the quality at point 2? Anyone? The quality at point 2. Sa condenser pa lang tayo entering. This is from point 1 to point 2 is, this is the turbine. Yan. Yan. So we have now 0.8643. Quality natin is 86.43%. Okay. Ano yung hahanapin natin at point 2? Reduce of the enthalpy at point 2. Yung importante lang hinahanap ni Mama to determine the cycle efficiency. So we have now enthalpy at point 2. At same table Table 2, page 8. We have HF2, 251.40. Sa quality, ano yung HFG natin? 2358.3. So this is now your enthalpy at point 2. Compute for the property. So we are just solving the properties from turbine, leaving the turbine. Kasi point 2 tayo. Point 2 to point 3. What is now your answer in enthalpy? Enthalpy at point 2. Wala. This is 86. What is now your answer, class? 2289. We have now 2289.68 kilojoule per kilogram. Okay. Considering that, we have now the enthalpy at point 2. Balik tayo dun sa TS diagram natin. From turbine. So, dito yung class the schematic and the TS. 2 to 3 is condenser. Condenser. We all know that all the properties at state 3 is a saturated liquid. Okay? So, yan po lagi yung assumption at state 3 or yung leaving the condenser, entering the pump. So, saturated liquid po yung palaging assumption natin. Saturated liquid. Since we all know that from pressure 2 to pressure 3 is a constant pressure process, yun po yung magiging basehan natin. Yung pressure 2 natin is 0.02 MPa. So, our pressure 3 is also equal to that. Using the same table. Okay. Using the same table, we proceed now to the saturated liquid values. Ano yung kailangan natin at saturated number 3? Yung specific lang is yung saturated liquid natin. And saturated liquid at specific volume at a saturated liquid at a given pressure. So we have now the specific volume at 0.3, which is equal now to the specific volume at 0.3. So that is now equal to 1.0172 times 10 to the negative 3 per kilogram. And we also have the HF at 0.2. Yan, para hindi kayo. That is now your H3, which is equal to 251.40. 40, tama. 21.40. Tama yung H3 ko. HF2 kilojoule per kilogram. HF 1.01. Ayan. 251.4. Okay. Okay, so we have the properties at 0.3. So we now proceed in solving the state 4 class. In state 4, we don't actually use step table but prefer to use the energy or the approximate work of the pump. Okay. So, pag sa state 4 class, kadalasan ginagawa para makuha yung values natin is, para makuha natin si H4 natin, we make use of the work of the pump. We have the specific volume at 0.3, pressure 4 minus pressure 3. Alam naman natin that the pressure 4 is just equal to pressure 1 and pressure 3 is equal to pressure 2. Yung pressure at 0.1 natin, given sa problem that is 7 megapascal and this is 0.02 MPa. We need to compute first for the work of the pump. Specific volume. Yan, substitute mo lang. Ano yung pressure mo at 0.4? That is 7 MPa minus 0.02 MPa. What is now the work of the pump in kilojoule per kilogram? Sige nga. What is now the work of the pump given sa atin yung different pressure? So, pinaghalo-halo na yung different properties. Dapat alam niyo kung ano yung nangyayari dyan. 4 to 3. So, may pump tayo dito. And 4 to 1 is the boiler. Diyan nangyayari yung boiler na. So what is now the work of the pump? Wala. Work of the pump. Huwag kakalimutan yung times 10 to the negative 3. Okay, yan. May answer na si Adeline. We make use 7.100. Ilan yung 0? Tatlo. Dalawa. Zero. Ilan yung nakuha nyo? Bakit mali? Tama yun. 1.0. Tatlong 0. Ayun. Yeah. So, gagamitin natin is the work of the pump at 7.1. Ayan. Kilojoule per kilogram. Kasi 5.6 to. 0.056. Yan. 0.0. Oo, pwede. 1, 2. Ayan. Ayan. Tama. 0.0. Ayan. Bakit ayaw? Okay, balik tayo. Okay. So, we have now the work of the pump. But we all know that pag hindi nyo class alam, i-draw nyo ulit. Balikan nyo tong schematic. Yan, schematic diagram sa may pump. Pag hindi nyo na alam yung gagawin nyo, energy equation ka ulit. Pasok dito yung 3, lalabas yung 4, at saka may work of the pump. Diba? So, all entering H3 plus work of the pump. So, in finding for the H4, we make use of this plus the work of the pump. Yan. Sige nga. Ano nga yung H3 natin? We have now the H3. Ano kasi yung H3 natin? Excuse me. In computing for the H3. Ayan, dito na. 251. Ayan, thank you. So, H4, we have 251.4 kilojoule plus work of the pump. Ayan, 4 decimal lang naman. So, what is now the H4 in 2 decimal? The enthalpy at 0.4. What is now the process? Ayan. 200. Ilan class? 250. Yan. 258.5. 258.5. Tama. 58.5. 41. Ano yun?
Ma'am, question lang po, ma'am.
Opo.
Yung sa work po, ma'am, yung 7.2,
Opo.
wala po siyang, ano po, ma'am, yung times 10 raised to negative 3, tatanggalin po yun?
Okay. Sige. Good question. Okay. Take note that here, we have lagyan natin ng red. This is times 10 to the negative 3 and this is in MPa. Okay. In putting in your calculator, para hindi kayo maguluhan, ilagay nyo dyan 0.001. Ayan, isulat mo yan sa calculator mo para eksakto ka. This is now in cubic meter per kilogram. And yung 7 Pascal mo, i-kilopascal mo. kilopascal minus 1 to 20 kilopascal. Yan. I-compute mo yan. Ano matitira dito? Sige nga. Calculator, in your calculator. Kasi ang matitira dyan sa'yo dapat is yung kilopascal natin is kilonewton per meter squared. So, kakancel yan. Yan. Cancel to. Matitira isa. To. Matitira sa'yo is kilonewton meter per kilogram. Your newton meter is in joule, so kilojoule per kilogram. So, what is now the answer here? Yan. In 0 point. Parehas lang ba? Sige nga. What did you find? Okay. So, that is same para mas maintindihan ng classmates nyo. So, ganun po. 7.100056 kilojoule per kilogram. This is now your work of the pump. Yeah. So, same lang sila. Yan. Pinakita ko lang dito yung times 10 to the negative 3 mo. Na ganito. And your MPa into kilopascal. Nasagot na po ba? Okay. Balik tayo sa work of the pump. Okay. O, ano yung answer nyo dito? 251.4 plus 7.1. Okay. Ano yung sagot? 250. Yan, malayo. Kilojoule per kilogram. Tama yung H4 nyo? We have now the enthalpy at 0.4. So, wala pa tayong sinusolve, cycle efficiency. So, this is now your, para makita nyo, bang color. Yung color gusto nyo. Ito. This is now your, from 0.1 to 0.4, that is your 7 MPa. This is 0.02 MPa or your 20 kilopascal. This is 7.0 MPa. Yan. Naintindihan po ba to? 258.5. Okay na ba? Can we proceed now? From that point from that reference. Okay. Naintindihan na ba class? H1 to H4. Ayan, nakuha na natin si H1 hanggang kay H4. Ano yung gagawin na natin? We'll compute now for the work ng turbina natin. Ayan. Entering. So, we have now the turbine. Pag hindi nyo na class, i-draw nyo na lang. Ayan. Entering, leaving. How do you get the work of the turbine? H1 work now of the turbine is H1 minus H2 from your energy equation. What is the H1? Balikan natin. 35.35. Yan. What is the H2? 2 to 89. Check na natin. 0.68. So we have now the work of the turbine. What is now the work of the turbine? One, two. Yung iba, 35, 30.9 minus 2 to 89. 8. Okay. We have now 1, 2 for 1.22 kilojoule per kilogram. Ayan. Di pa tayo pinapahanap sa atin is the cycle efficiency. We all know that we have now, excuse me, yung work ng pump natin, nakuha na natin class. Okay. Yung work ng pump natin, nakuha na natin. So, take note, yung work ng pump natin, pump, negative work po yung nagagawa niya, class. Negative work. Okay? So, if we, kung babalik na rin lang naman to, class, we have the work of the pump. Negative work. So, dito na yan sa work net. Okay, in solving for the work net or the net work, ayan, we have the work of the turbine. Addition siya class ng all ng work. But take note, yung pump natin has a negative work, so ito na yung pinapagamit ko sa inyo para hindi kayo malito. Work of the turbine minus work of the pump. So, finding for the work net, we have now the work of the turbine minus work of the pump. 7 point. Yan. Gamitin lang natin yung 4 decimal. Okay, we have now the work net. Ano na po yung work net natin? Ayan. Yung net work. What is now your answer, class? 1234, 1241, 7.1. We have now 1234.12 kilojoules per kilogram. Okay. After that, we need to find the heat added at the boiler. So, if this is your boiler, labas dyan is yung H1, entering is yung H4. Heat added, the heat added or the in, okay, the heat in the system. Okay, so heat addition, yan, pag hindi mo alam yung formula, hindi energy equation ka, H1 minus H4. Okay, finding for that, we have na the QA, H1, ito 3530.9 kilojoule minus H4, 258.5 kilojoule per kilogram. So we have now the heat addition. What is now the answer? 35, 30.9 minus 258.5. Yan. We have 32, 3,272.4 kilojoule per kilogram. Yan, nakuha na natin. So, in finding for the thermal, anong pinapanap sa atin? The cycle efficiency. Okay. In finding for the cycle efficiency, yan. You can always have the work net over the heat added. So, what is now the work net? Total 34.12 kilojoule per kilogram divided by the heat added. Okay. Okay, so input divided by the output. Okay, that is the efficiency. What is now the efficiency? Yeah. Approximately 1 hour magsusolve para sa isang cycle efficiency. Okay, what is now the cycle efficiency? We have now, what is now? 12 divided by 3272.4. Yes, we have 37. Ano yung answer ng iba? Give now 37. Ayan. 37.70. Ano sa inyo? Ayan. 51%. So this is now your final answer in solving a ideal Rankine cycle. Okay?